to be with you all virtually. I should start most importantly, this is joint work with Avi Akaria, who's at Stanford Poli Sci, and João Ramos, who's at Queen Mary, both of whom are obviously terrific. I guess I should say that the starting point for this project is, to put it lightly, not new. So kind of where we start from is that politicians in office are subject to a moral hazard problem. All right, so think about voters. Voters want politicians to serve their interests, serve the voters' interests while a politician is in office. Voters are going to observe something about the outcomes of politicians' actions, but the things that voters observe are only going to reflect politician effort imperfectly. I see some outcome. I see that things didn't go very well this quarter. I don't know whether it's because you acted not in my interest, or because of circumstances that were outside your control. I'd say the kind of the benchmark model, or the model that we want to think about when we're thinking about this moral hazard problem, is the Ferrajan model. So this canonical, seminal 1986 paper gives a model in which voters, in the face of this moral hazard problem, voters' behavior serves to incentivize politician effort. And so what Ferrajan studies is stationary retention rules. So basically, I have a history independent cutoff, sort of how good an outcome I expect of my politician, and I'm going to and in any given period, I'm going to re-elect a politician who attains at least that threshold level of success for me, and otherwise I'm going to replace them with a new politician. And so this simple model gives us equilibrium retrospective voting, and so at least partially it resolves the moral hazard problem. This model, as opposed to, or in addition to giving us kind of giving us a possibility result for retrospective voting that occurs in equilibrium, it's also a terrific workhorse model, as the large literature that follows and builds on Ferrajan shows. So what we're going to do is a somewhat uncreative exercise. We're going to revisit the Ferrajan model, really a stripped down version of the Ferrajan model, and I'll clarify exactly how it's stripped down. We're going to revisit the Ferrajan model, and we're going to look at a different solution concept. So instead of focusing on stationary retention rules, stationary equilibria, we're going to look at a normative benchmark. We're going to ask, what is the voter optimal equilibrium of the Ferrajan model? All right. This slide, I'd say 1 and 2 are really a plan, and 3 and 4 are aspirations for the talk. Okay, so but all of these are in the paper. So what we're going to do is, so here are the kind of broad things we're asking. So we want to ask, what are the dynamics of voter optimal accountability? And what we're going to see is that when we look at voter optimal equilibrium, we'll find that it's, in particular, on the path of play, it's unique. And we're going to see that this unique equilibrium exhibits rich dynamics, rich career dynamics for a politician, in which they have job security that varies in systematic ways over the life cycle. And one feature that I want to highlight that happens under optimal political accountability is politician entrenchment. And we're going to see that in some sense, it's a necessary feature, an inevitable feature of voter optimal equilibrium. So the second thing we're going to ask is, especially motivated by this entrenchment outcome being a pretty terrible outcome ex post for voters, in which politicians are exerting, have extreme job security and are putting in very little effort, this is going to lead us to think about voters' credibility concerns. Now we are looking at equilibrium, and so in some sense we shouldn't worry about credibility. But you can have one could worry: what if voters could renegotiate away from bad outcomes? And we're going to see that similar dynamics can still arise in voter optimal equilibrium, subject to a renegotiation proofness refinement. But entrenchment comes in a softer form, and I'm going to talk about how, in some cases, renegotiation concerns can explicitly preclude stationary play. So third, given that, so I want to talk about kind of some extensions of the model. So given that politicians are going to have varying job security in office, this leads us to ask about the interaction with politicians receiving outside job offers while they're in office. So, in principle, if after some histories I'm happier to be in office than after other histories, that means that I might accept job offers after some histories and not after others. And so this is going to feed back into the form of optimal incentives. And what we're going to see, again, this part is aspirational in terms of timing, but what I'll hope to talk about is that it's going to be in the voters' best interests to have politicians take outside offers. And the broad intuition is that this entrenchment is a very costly reward to give to politicians, but it serves a purpose. It's incentivizing effort. And so basically, by having the private sector give politicians reward that they can only collect and receive these offers if they're in office to receive the offers, then basically I get to outsource the costly reward to industry, which is beneficial to the voter. And fourth, we're going to think about an extension of the model in which politicians have heterogeneous ability. So a model that has both adverse selection and moral hazard. And I'm going to talk about a novel dynamic sanctioning selection trade-off that can occur even in settings where the past literature would have told us that there shouldn't be one. Okay. So this is the aspirational plan. Let me just briefly say something about the literature. So of course, our paper sits squarely in the literature on electoral accountability, which I couldn't adequately survey if I spent my entire talk on it. And so instead, I've listed a couple seminal papers and a couple nice surveys. But in particular, this is the paper that we're building on. Now, just drilling down in a little more detail, we sit within a smaller, more recent literature that looks at non-stationary play in settings of electoral accountability. In settings of electoral accountability. So in particular, this paper looks at essentially looks at the Ferrajan model with some non-stationary equilibria, but looks at a particular restricted class of equilibria that, given our results, rules out the optimum. This paper looks at a model that has some moral hazard and some adverse selection on the part of politicians in a model with and without term limits, but in the model without term limits, focuses on a class of Markov perfect equilibria. And this paper, again, looks at electoral accountability in the face of both moral hazard and adverse selection, but its focus is on, in the limit, as players become very patient, when can the voter get good outcomes? Whereas we're interested in at fixed discounting, and indeed we'll see that we want to think about the case where discounting is not too high to keep our problem interesting. We want to know at fixed discounting, what are the actual dynamics of optimal political accountability that arise in equilibrium, in voter optimal equilibrium. And sorry, now finally, our paper is a paper on dynamic moral hazard. There are many papers on dynamic moral hazard. So, but as far as tools, we're using the standard recursive toolbox for thinking about these kinds of settings. And we join an extremely long list, of which this is a representative subsample of papers that look at a particular dynamic moral hazard setting, characterized to varying degrees of completeness what an optimal contract for a principle looks like, and interprets those results in its application of interest. And so, I'd say relative to this literature, if I wanted to give the theory pitch of what we're doing, we're looking at a dynamic moral hazard setting without transfers and with replacement of the agent. Okay, so now let me tell you the model, which, as I've said, is not our model. So I have a representative voter and an infinite pool of politicians. And every period, so time is discrete, every period I have a binary productivity shock. So a shock that takes value either 0 or 1, that's privately observed by the politician who's in office in the current period. Right? And let's say the probability of the good shock is mu, and this is IID across periods. So now the politician who's in office, having observed this shock, is going to exert an effort level, AT, that's a number between 0 and 1. The voter is going to get a flow payoff that the voter observes, everybody observes, which is just equal to the product of the two. Right. So in particular, if theta is 0, the outcome is 0. And if theta is 1, the outcome is equal to the politician's effort. The voter, having observed this outcome, decides whether to re-elect this politician, in which case this politician is in office in the next period, or to replace this politician, fire them and get a new guy. And in the event that they kick the politician out of office, we're going to assume, without loss of payoffs for the voter, we're going to assume that the politician never re-enters office if they're replaced. And so finally, I have to tell you what the politician's payoff is. So a politician, so they get a continuation value of 0 once they're out of office, but while they're in office, they get a flow office benefit that we normalize to 1, and they have a constant marginal cost of effort that's equal to C. And we're going to look at and so everybody has a discount factor delta, and for convenience, we'll assume that there's a public randomizing device that people can condition on. So this is not literally the model in Ferrajan. There are two differences between Ferrajan's model and ours. So the first difference is that Ferrajan has a continuous shock and we have a binary shock. The second difference is that Ferrajan has effort being unbounded and the marginal cost of effort being increasing, whereas we have effort being bounded and the marginal cost of effort being constant. So of course, this is for both parsimony and tractability, but we'd like to think of our model as a limiting special case of Ferrajan in which the cost of effort is C up to a point and then is infinity. Where that up to a point, we've normalized that point to 1. Okay, so are there any questions about the model?
I have one comment.
Please.
So I don't work in political economy, so I'm not familiar with the model that you are using. But the way you describe it is that by having a continuum of productivity shocks, that he had somewhat of a richer environment in the sense that with your binary productivity levels, when productivity is 1, then that's perfectly revealing of the effort, right?
Yes, right. So it's so what this is going to mean is that even though even though there are continuum many actions I take, the only action the only outcome you could observe at which you wouldn't know exactly what my action is 0.
Right.
And that's and that's special to the binary shock model and helps us.
So his model didn't have this feature.
That's correct.
All right. Okay.
Yeah.
A quick clarification question. Do you impose assumptions on little c?
For now, no. But it's coming. Yeah. So okay. So let me let me just as a warm-up kind of redo the Ferrajan analysis for our stripped down version of his model. All right, so let me think about stationary cutoff equilibria. So I'm going to think about equilibria parameterized by an effort level A hat, such that I'm going to re-elect the current politician if and only if today's outcome is at least A hat. All right, so it's easy to deduce that the only plausible best responses for my politician are to shirk, so to choose 0 no matter what, or to shirk when the shock is low and choose A hat when the shock is high. All right. Why exactly that's true, I'll end up going through it in more detail later when we're doing our fuller analysis, but just take that for granted for now, that this is sort of the relevant deviation for the politician. And so what does a politician who's currently in office get as a continuation value if she shirks? Well, that means that I get my office benefit with no cost of effort for today, and I'm sure to be fired tomorrow. And so my continuation payoff is 1 minus delta. Now, what happens if I work today? We'll let you be the continuation payoff of a politician in office who behaves the way they're supposed to, who works. Where when I say works, I mean works if the shock is high. Well, then what happens today? Well, today I get my office benefit and I pay a cost commensurate with effort level A hat if and only if the shock is high. And what do I get from tomorrow onward? Well, nothing if the shock is low, but if the shock is high, I get a continuation value U because this equilibrium is stationary. All right, so we can rearrange this to a formula for U, and we can further rearrange this. I'll spare you the moving pieces around, and we learn that working is incentive compatible if and only if this A hat level, where by working I mean putting in effort level A hat, that's if and only if this A hat is less than or equal to delta over C. All right, so it's now worth distinguishing two cases. And now, so I'm a slide late answering you, Anton. So in the first case, delta is higher than C. Well, in this case, basically what we've learned is that Grim Trigger incentivizes first best. I fire you if you ever don't give me a first best outcome, and that's going to get you to give me a first best outcome whenever it was feasible for you to give me a non-zero outcome. So in this highlighted case, we found a stationary equilibrium that gives the voter first best. For the rest of the talk, I'm going to assume that delta is less than C. All right, so it might have been natural. I think it's natural for a lot of applications to think of C being in between delta and 1, but whatever. The relevant thing that I want to take for granted for the rest of the talk is that delta is less than C. Okay, so this is what I mean when I said what I meant when I said the players are not too patient. And so this is when I have a kind of a binding moral hazard problem. All right, so in this case, the best stationary equilibrium has this interior effort level of delta over C being chosen. All right, now let's just observe that we can do better. All right, I know you can engage in forward induction and see how much time is left in the talk and what the paper's about and infer we can do better. But let me show you. So let's take some parameters. Let's take some parameters. say, you know, the shock is good with probability 4/5, the discount factor is 3/4, the cost of effort is C. And so we already have the value to the voter of the best stationary equilibrium, right? It's I get A hat whenever the shock is good, period by period. And so, you know, we can do the algebra and get that my payoff is a fifth as a voter. All right. Now let me point to like a simple contract or simple equilibrium that does better. All right. So what I could do, I'll just tell you about what happens on path. So what the voter could do is tenure the politician if any politician who in their first term in office gets an outcome of 1. What I mean by tenure you is you're in office forever. And no matter what happens from now on, if my first outcome is 1, and if your first outcome is anything other than 1, anything other than this first best outcome, I fire you. All right, so I've just reinvented the tenure track. So what is the you know, what are the payoffs that I'm going to get? Or sorry, the first thing that I should verify is that work is IC for a politician. All right, so clearly, you know, once I'm tenured, I'm subject to no incentives. I don't like to put in costly effort. I put in an effort level of 0, and my continuation value is 1 once I'm tenured. All right, and so what do we need to compare to see whether work is worth it? We need to compare the myopic cost of putting in full effort, conditional on the shock being high, against the discounted marginal benefit of being tenured rather than being shit-canned. All right, and so I just have to compare this to this. The parameters I've given you, it turns out that, you know, what I need is this inequality. It turns out that they're actually equal here, but that's good enough. And so what I've learned is that work is IC for the politician. And so what value does this give to the voter? Well, the voter's payoff is equal to, so in the first period that a politician is in office, if the shock is high, I get a payoff of 1 this period, and then I'm never getting 0. I'm never getting anything but 0 ever again because I'm tenuring somebody. But if the shock is low, then I fire them, and from tomorrow onward, I get to start the same equilibrium with a new politician. All right, and so we can rearrange this for a formula for pi, and doing some numerical work that even a theorist can do, we see that the payoff is higher. All right, and so this immediately tells us that the Ferrajan stationary equilibria are in general suboptimal. All right, so what is optimal? Let me just make some simplifying assumptions that are going to help us think in a more organized way about the shape of voter optimal equilibria, right? So before I should take a breath and check, are there any questions about this so far? Okay, cool. So some simplifying observations. So first, there's a bad equilibrium out there. Right, so there's always an equilibrium. Basically, I could take my A hat equilibrium where I set A hat equal to 0. This is the, you know, always, for example, always replace, always shirk equilibrium. And so this thing gives first worst payoffs to the voter. And so the fact that I have this equilibrium and that the voter doesn't have any private information and that the voter is not acting simultaneously to anybody else quickly tells us that voter IC is easy, right? So I can punish the voter for anything. And so what this means is that as far as the on-path characteristics are concerned, it's good enough for me to solve the commitment problem for the voter. solve the commitment problem makes it sound like something else. It's good enough for me to solve the contracting problem in which the voter has commitment power. And so it's really just a principal agent problem where the voter offers a contract to which the voter is committed to the politician in office, and I just need IC for the politician. So then, given that, it's without loss for me to assume that the politician uses a pure strategy, right? So basically, all right. So here's the lazy almost right answer. Almost right because this is good enough at the optimum, but the lazy almost right answer is, hey, whenever I was indifferent between working and shirking, I may as well work, and that's better for the voter. All right, so that lazy answer isn't quite an argument because without knowing the exact shape of the equilibrium, I don't know, first of all, working and shirking is like a pretty coarse description of behavior in this continuum action world. And second, the voter may, after some histories, want me to work less hard. So the slightly more careful version is if I as a politician were indifferent between two actions, and which I would have to be mixing over them, then one of them is weakly better for the voter. At least one of them is weakly better for the voter. Let me just use that one. It's IC, and I'm getting a weak improvement for the voter. Right? Slightly more annoying version of this can make the same argument work if I had a continuum mixture over actions. All right, so basically, next, I have an easy to see necessary condition of incentive compatibility for the politician rather, is that when the shock is 0, I choose 0. Right? This is when the shock is 0, my choice doesn't affect the public outcome, doesn't affect my future in office at all. And therefore, why would I exert costly effort? And so then if I combine these, I've learned that, at any given history, I'm going to have some action between 0 and 1, some effort level such that the politician is supposed to choose in equilibrium A if the shock is high and 0 if the shock is low, such that and so that much is just this observation. But now I want to say that it's without loss for every outcome that's at least as good as A to be treated equally, and I'll call those successes, and every outcome that's strictly lower than A to be treated equally, and I'll call that a failure. And so basically what I'm doing is when I'm taking, like if I treat these things in this way, if I treat everything less than A the same, and I treat everything that's at least as good as A the same, I'm now making it so that, so I'm not changing anything on the path of play, but all I'm doing is removing incentive constraints for the politician. I'm making it so that the only possible things the that the politician might want to deviate to are of the form choose 0 when I'm supposed to choose A, right? Because I now, as a politician, why would I ever choose something strictly between 0 and A? I'm better off choosing 0. And why would I ever choose something strictly higher than A? I'm better off choosing A. So I'm basically, this is just, it's more, punishing off schedule deviations. Okay. And so now, so what have we, so summarizing all of this, I'm left with the only IC constraint in town, which is that the politician, when their shock happens to be the high shock, the politician prefers to choose the effort level that they're supposed to choose rather than choosing 0. This is the only IC constraint at a given history for my politician, at a given public history. which I'll sometimes just lazily call the effort level A being incentive compatible. Right? So are there any questions about these simplifications? Okay, so the next one is, so now I said I have a public randomization device. And so given that I have a public randomization device, my set of payoff profiles that I can attain is a convex set. And what that's going to give me for free is that without, so I have just this single scalar IC constraint that I'm not bothering to write algebraically right now, that says as a politician, I weakly prefer to choose A when the shock is high rather than choosing 0. And that my set of payoffs is convex tells me that without loss, I can make this incentive constraint bind. All right. So basically, if this was my payoff vector I was going to give you when I saw success, and this is the one that I was going to give you when I saw failure, I can move them closer together to keep their average value the same until that constraint binds. And so I get without loss that this incentive constraint is always going to be binding. So all of this is just toward finding some voter optimal equilibrium. I'll say stuff about uniqueness later. Okay. Because, you know, if I wanted uniqueness, I would want to make like a strict convexity argument, and I'm not there yet. Okay. So, okay, so let's just combine all of this stuff. And I want to point out that just by combining these trivial pushing notation around observations, we're weirdly close to a complete characterization of voter optimal equilibrium. All right, so what we're going to do is the standard trick of, you know, looking at things recursively using the politician's continuation value as a state variable. All right, so what are the possible continuation values U that a politician who's currently in office can have? Well, the very best thing I can offer you is tenure, in which case you get office benefit forever and never face any costs of effort. The very worst thing I can offer you is I can guarantee you that you're fired between this period and the next period, no matter what happens. And if I do that, you will shirk and you'll get your office benefit of 1 for today. And so your continuation value would be 1 minus delta. And by mixing between these, I can give you anything in the interval. And so this is the domain of of incumbent continuation values, or I should say of in-office politician continuation values. All right. So now let me just black box some algebra. All right. So the question I want to ask, I'll give you formulas for it, is what must a voter's or a politician's continuation value on average be tomorrow if 3 things happen? So 1, I have this effort level A such that I'm going to ask them to put in effort level A if their shock is high and 0 if their shock is low. The public outcome turns out to be Y, and I'm offering continuation values in such a way that IC binds, that the agent is indifferent between A and 0 when the shock turns out to be high. All right, so it turns out that, all right, well, let me just say, so notice I have 2 equations and 2 unknowns, right? I'm supposed to deliver you continuation value U. That's 1 equation. I'm supposed to make you indifferent between, working and shirking. That's 2 equations. And my 2 unknowns are continuation value for success and continuation value for failure. All right, so of course there are formulas. I mean, it's 2 linear equations that are, linearly independent and 2 unknown. So of course there are formulae, but let's see what they are. So first, I have this one for failure and this one for success. So the failure one is easier to think about. So I'm making you indifferent between working and shirking. Therefore, your continuation value would be you, even if you were to just decide to shirk. Right? And so this is why, so if you were going to shirk no matter what you would get is your office benefit of 1 from today and your failure payoff from tomorrow onward. And so I can compute your failure payoff from tomorrow onward by taking your continuation payoff from today, subtracting off your accrued office benefit from today, and renormalizing for discounting. Now, what about if you're successful today? Well, I have to make you indifferent between working and shirking today. And so let's just take your conditional on a shock. That's the reason, on a high shock. So it's sort of, we're already conditioning on the shock, and that's why mu isn't showing up in this formula. So basically, this success payoff just has to be CA corrected for discounting higher than your failure payoff in order to make IC bind. All right. So the things to notice about this formula are both of these are strictly increasing in U. The failure payoff doesn't depend on the effort level. The success payoff does depend on the effort level and is higher the more effort level I'm trying to get out of you. And a thing that I wouldn't expect you to read off of the algebra, but that is true, is that the success payoff is higher than your current U and the failure payoff is lower than your current U. Okay, so we have these formulas for continuation values. So what's left to solve for is at a given U. So I guess two things. One is at a given U, what effort level do I want you to put in? And so all that's left over is the one thing that matters. And then I also have to figure out, so it's basically everything is figured out except behavior. I also have to tell you, for a given average continuation value from tomorrow onward, how much, so what's the rate with which I want to fire you? So intuitively, I'm going to give you some continuation value V, and you can check that if U was between 1 minus delta and 1, this V is between 0 and 1. And so what I'm going to do is I'm going to mix between firing you for a continuation value of 0 and retaining you at some continuation value that's in between 1 minus delta and between 1 minus delta and 1 in such a way that they average out to this V. And so I still have to solve for the firing rate and the behavior. And so our kind of main proposition tells us the solution to these. All right, so basically, you don't need to look at the formulas. The relevant features of this are, I'm going to have your effort level be the highest effort level that I could possibly get out of you, given the continuation value I currently owe you, subject to IC. So it's sort of, there's the most effort I can possibly incentivize from you, the effort level that I would incentivize from you if I said the highest one such that if I told you you'll be tenured if you put in that level and you'll be fired if you don't get that level, the highest one such that that would make it IC. That's how much effort I'm going to get out of you. That's not the way I'm going to get it out of you, but that's how much effort I'll get out of you. And my firing rule is going to be roughly, I will fire you as little as possible subject to promise keeping. Okay, so we can think of these as two instances of the same familiar phenomenon, which is I want to backload costly incentive provision. So I'm getting as much effort as I can out of the current politician in the short run as possible. Okay, great. And so that's all this is saying. I'll show it to you in a picture in a second, sort of what these dynamics look like. Some features that kind of, oh yeah, so sorry, another big point that I left out is where I start a politician. So I'm going to actually systematically want to start a politician at a continuation value of 1 minus delta. What that means when I'm starting you at the lowest possible continuation value is that if you fail your first term, you're fired. The other thing that I want to point out is that, you know what, actually, I'll just wait for, I'll show you the picture. Okay, so let me give you kind of, you know, an idea of what the equilibrium path of play looks like. All right, so here I have the interval 0 to 1 and the important interval 1 minus delta up to 1. So where do I start a new politician? I start them at a continuation value here. And so what I want to do is I want to have them put in as much effort as possible. Suppose delta is high enough that it's possible for me to get them to put in effort level 1 today. I think that means delta is at least C over 1 plus C. Then what that means is, so I'm going to have some continuation value that we've solved for. That's what happens when you plug in A equals 1 into that V formula. That sort of the payoff that the continuation payoff that they're going to have if they are successful, if they get me an outcome of 1 today, and the continuation value, which turns out to be exactly 0, that I'm going to send them to if they fail today, which is on path because they could just get a low shock. And so, all right, so if they fail, they're going to be fired. Suppose they succeed. And so now their new continuation value is here. And so now again, say my parameter values are such that I can still get them to put in effort level 1. And again, going to have them, I'm going to punish them if they fail today, and I'm going to reward them if they succeed today and move them here. So suppose they fail today. So now this continuation value for the politician is low enough that to satisfy promise keeping, I must fire the politician between this period and the next with positive probability. So what I'm going to do is I'm going to fire them with the lowest possible probability I can. So I'm going to fire them with some probability, and with complementary probability, their continuation value will be 1 minus delta, as though they were starting their career anew, in such a way that their continuation value is on average what I was promising them. All right, so now suppose the politician has like a string of successes from here, and now their continuation value is high enough that even if I were to tenure them for a full success, like for a first best outcome, and fire them for any other outcome, that wouldn't make it worth their while to put in high effort. So now what I'm going to do is I'm going to offer them a punishment that's the same as before, but the reward that I'm going to offer them is just the highest reward I can for tenure, but I'm going to give them a lower standard of success. Okay, so basically I'm going to have them choose the effort level A that makes their IC bind when I offer them tenure for success and the usual failure payoff for failure. And then, you know, let's say they succeed. Now they're here. You can trace out the dynamics that I showed you before and check that in particular, they're now going to put in 0 effort forever and be retained forever. And so they will become fully entrenched. So let's look at kind of, you know, just a simulation of a few sample paths. So where I have a politician's continuation value over time, where for each one of these sample paths, I've started, you know, at time 0 corresponds to not time 0 to the voter, but that politician's beginning in office. And so notice a couple things. So one, politicians, some of them don't make it. So some of them end up being, you know, fired eventually. And in fact, all of them eventually end up getting fired or tenured. Some of them get tenured, And moreover, their, their continuation value, which I can think of as their some, scalar summary of their job security is like is broadly increasing over time. Okay, this is true in an asymptotic sense. It's not true even on average, literally, as I go through time because of integer issues. But broadly, their job security increases over time. And so an important corollary is that sort of in any voter optimal equilibrium, so first, I told you before, a first term failure is going to lead to replacement, but also it's a probability one event that some politician is eventually tenured, right? Because if I fire a politician, I get a new draw of this stochastic process. And so eventually one of them is going to make it and be tenured. All right. So I just want to point out that this isn't, purely the stuff of science fiction. So our model, I really do want to think of our model as a normative benchmark, but like political entrenchment does happen. So, with apologies for this America-centric, example, there are politicians whose job security is, somewhat extreme. Okay, in a particularly extreme case, there are politicians whose job security extends beyond the grave. So you can look at what's now Michigan's 12th congressional district has contiguously been served by John Dingell Sr., John Dingell Jr., and Debbie Dingell for a collective, I think, 88 years of Dingell representation in Congress. Now, I don't want to say that this model that has moral hazard in it and that's the only moving part is like the reason for political entrenchment. But what I will say is that there's an empirical literature that talks about various potential causes for entrenchment. And I think at the very least, our model points out a non-trivial identifying assumption that needs to be made about equilibrium selection, namely that, you have particular equilibrium being played that rules out voter optimal play. If you want to infer from something like entrenchment that, political accountability is not functioning, or if you want to infer that, if you want to infer other causes for entrenchment. Okay. So let me, I've horribly mismanaged time, but let me say something about limiting voter commitment. So this entrenchment outcome, let's notice there are, in fact, not just there exist histories, but with probability one on the path of play, we reach a history at which the voter's continuation value is first worst. Right? This is like entrenchment is very costly and it happens in this model. And so taken literally, this is not requiring any commitment power from the voter, right? This is happening in an equilibrium. But, we might worry, is this equilibrium credible if we think voters might be able to renegotiate away from bad continuation play? All right, so let me, give one notion of renegotiation proofness, which is we could look at equilibria where there's some threshold payoff such that we say that voters should be able to renegotiate away from the current equilibrium if their continuation payoff is below this pi lower bar. All right, so I'm aware this is kind of ad hoc. We can there's an argument to endogenize it, but the first thing I want to say doesn't really have anything to do with what this pi lower bar is. And so I guess what I want to say is the voter optimal equilibrium subject to this bound has extremely similar dynamics. Okay, the only difference is that I have some upper bound on entrenchment. So an upper bound U hat on the politician's continuation value. And then we're basically just going to solve the voters problem where I solve their optimal contracting problem subject to the additional constraint that the politician's continuation value is never allowed to exceed U hat. And this has extremely similar dynamics. So I have the same formulas for continuation values. I still fire as little as I can get away with, and I still have you put in the highest level of effort that I can incentivize, subject to respecting this U hat upper bound. And so, but then this means that when I hit U hat, it's not perfect tenure. When I'm at U hat as a politician, I'm going to be expected to put in some small amount of effort if I want to stay at U hat rather than being moved down to a punishment payoff. Now this, in particular, if this pi lower bar is anything, or sorry, if this U hat is anything strictly larger than 1 minus delta, we're getting non-stationary equilibria, even with this credibility concern. But this still leaves open the possibility that U hat is equal to 1 minus delta, in which case I've just given you an obnoxiously fancy description of the Ferrajan equilibrium. And so it's, what we would like to know is if I endogenize this pi lower bar and therefore endogenize this U hat, do I end up getting non-stationarity? And so how would you endogenize it? So here we want to borrow from Pierce 1987. So I should say Pierce, beautiful paper on renegotiation proofness that is focused on symmetric equilibria of symmetric repeated games. However, we think his argument seems equally valid for thinking about unilateral renegotiation by a principal in principal agent settings that have some recursive structure. And so the idea is that, say we're playing some hypothetical equilibrium and we're at some continuation value. Suppose there existed some alternative equilibrium such that history by history, the continuation value in the new equilibrium was going to be higher than the current continuation value. Surely renegotiating to this alternative, making a speech saying, hey, let's play this other equilibrium should be credible. All right. Now, what about, so say I'm playing some equilibrium and I'm at some continuation value, and I point to another equilibrium and I say, hey, this other equilibrium would give us a higher value. But suppose that other equilibrium would have histories at which my continuation value would again creep down to where it is now or lower. Well, then you shouldn't believe my speech about which equilibrium we're going to play, because you should think I'm going to make another speech in the future, like another similar speech in the future. And so what this leads us to, apologies that I'm going a little quickly over this logic, but what this leads us to is a natural notion of an endogenous pi lower bar, which is basically it's the highest pi lower bar such that some equilibrium exists for which all continuation values are above pi lower bar. And the idea, and so it's basically this is the pi lower bar that credible renegotiation should select. And so, but then you can write, you can be a little fancy and just describe the renegotiation concern without actually naming the pi lower bar, and equivalently say an equilibrium is Pierce renegotiation proof if it maximizes the infimum continuation value over all histories. So if we get pi lower bar like this, then we're getting, in some sense, the natural outside option for the voter. And so we show for a range of parameters that U hat has to be strictly greater than 1 minus delta. And so in particular, what this means is that a credibility concern can, for some parameter values at least, explicitly preclude stationary play. And we think this is important because, kind of commitment problems is I don't know, for me anyway, I feel like commitment problems is one justification that I'm used to hearing as a justification for restriction to MPE. And so, okay. So given timing, I'm going to, let me tell you very briefly what these models are. So we look at it. So this is now just plainly advertising for the paper. So we look at a model where we augment the current model by saying that politicians have an outside offer W, which in the interesting case is in between 1 minus delta and 1, that they stochastically receive any period in which they're in office. All right, and this gives us a kind of interesting, this gives us a scope for interaction with our non-stationary equilibria, because they're going to want to accept offers when their continuation value is low and reject offers when their continuation value is high. And in particular, this will be history independent. And so what we, and this, you know, this is compatible with some empirical evidence, but so the result that we have is, so first we kind of just solve up to a parameter. We solve for voter optimal equilibrium, and the main feature that I think is interesting is that when this outside offer is close enough to 1 but still strictly less than 1, then it's strictly optimal to look at equilibria in which I keep your continuation value below W, so that I make sure you want to take your outside offers. And the reason is, when you take your outside offers, I'm freed of you, and I get to take a new politician to whom I owe nothing. So now, so I'm kind of outsourcing this costly reward to the private sector. And finally, we look at a model where politicians have heterogeneous types, and a model, so in particular, a model where there are politicians who are unable to succeed and there are politicians who are able to succeed. And so what that means is, if you thought about a planner problem, throwing out agency issues, this is kind of deciding what to do with a politician would be like a perfectly revealing good news experimentation model, because either they're successful and I perfectly certify them, or they fail and I gradually learn bad things about them. But it turns out that you can solve this model with essentially our exact techniques and our exact characterization kind of easily, because since I can costlessly replace a politician who has had a little bit of failure with a fresh draw, it's always to my benefit to do that. And therefore, the only politicians that I'm ever dealing with outside of a first period politician are ones who I've certified as high types. And this argument, you know, the agency problem doesn't mess with it, because if I'm going to definitely fire you for failing in your first period, I'm just helping any incentive issues. I'm just giving you stronger incentives. So this kind of speaks to stuff that's been already seen in like 2-period models, which is that I don't have a sanctioning selection trade-off if effort and ability are complements, as they are in this model. But what we see, and I unfortunately won't, you know, get to tell you much about the detail or anything about the details of it, is that because we're looking at a model with rich dynamics, we're able to uncover, even though effort and ability are complements, we're able to uncover a novel sanctioning selection trade-off between today's sanctioning, namely the effort of the current politician, and tomorrow's selection, namely the trade-off between keeping a current vetted politician and having to go back to the pool and wait around until I find another high type. And so, okay. Anyway, I think I'm now over time, so I I guess, yeah. So I guess all I'll say is we look at kind of essentially the Ferrajan electoral accountability model. We see that rich dynamics that are also kind of plausible dynamics about evolving goodwill of politicians show up in the unique voter optimal equilibrium. And we see that we can get new economic lessons by varying the framework in ways. And so what I'm hoping that this paper makes a case for is that if we kind of take this model that's literally older than me, and we take the training wheels off of it and strip it of its traditional focus on stationary incentives, what's left over is a versatile, tractable framework that lets us ask substantive questions about the dynamics of political accountability. Okay, so sorry that I'm 2 minutes over, but thank you very much for your time.
Well, that was really impressive. Any question for Elliot?
Yeah, I have a question. So you focus on voter optimal equilibria, but your analysis seems to suggest that everything applies to Pareto optimal equilibria because, like, you fix the continuation value of the politician, and you find the best value for the voter. So you can potentially make a stronger statement that all the results that you have apply for all Pareto optimal equilibria.
So two caveats. One is not the result about being fired for your first term if you fail your first term in office, because that was about the starting value. And the second caveat is Pareto for whom? There are infinity plus one players in the model. And so if you mean Pareto for the initial politician and voter, then I agree.
Okay, got it. Thanks. So actually, I have another question.
Go ahead.
So do you do much on this long run distribution of being fired versus being entrenched, and how it depends on the parameters of the model?
No. So you mean like what? So I have a probability that I'm eventually entrenched or eventually fired, and you're asking just comparative statics with that outcome, like that probability as the outcome.
Right. So comparative statics on the parameters.
Yeah. So we haven't thought about it. It wouldn't surprise me if doing very little work, we could derive it from kind of from something that from a related calculation of these like absorption probabilities in Guo and Horner. But anyway, we haven't thought about it. But it's a good question.
Any other question?
Well, I can ask another one. So the most restrictive assumption seems to be that the theta low is equal to 0. So have you thought about the case like theta L greater than 0 and theta H equals to 1?
Mm-hmm. So theta. So just you're saying, so I have two different positive levels of theta.
That's right.
So we haven't. I expect it's tractable, and I expect that's the hardest thing that's tractable. Like meaning basically this to get similarly complete answers, the binary shock is the most I would hope for. So by the way, I'll point out that So I could have written a model. So we wrote the model the way Ferrajan did, which is the politician observes a shock and then chooses an effort, and the outcome is a deterministic function of the shock and the effort, right? And you could have, a more natural model, to those of us who have seen 1001 dynamic moral hazard papers, would have been, I choose an effort level, and then this stochastically maps into a shock. Given that the shock was 0 or 1, this is just a relabeling of notation. But once the shock is not 0, we're no longer in a model that's obviously equivalent to that standard moral hazard model. Now, it's that doesn't mean that it's obvious. That doesn't mean that it's intractable. I still think that the sort of the way, like what we would retain in the model you're proposing is that even though I'm making continuum many choices, because I think of you choosing a pure strategy, in some sense, I only have to worry about 2 on-path outcomes at any given history, and that would remain true in the modified model that you're describing, and that's the reason that I'm hopeful that it would remain tractable. But I want to point out that it's sort of the model will feel less like a dynamic moral hazard model that you're used to when this thing is not 0, because that equivalence breaks.
Thanks. Yeah, that's a very great and helpful point about that this model is equivalent to a moral hazard problem.
All right. Thank you for the question.
Any other question? So if there's no other question, please join me in thanking Elliot for this wonderful talk. Elliot, you didn't disappoint, so thank you very much.
Thank you. Really appreciate you having me.
And